So for the carving effect, let's drop down a carve node, and we don't want to use the first two. This will cut from the bottom. We want to cut from the second. So like this. But again, we don't want this to be uniform. And as you can see here, we can use an attribute to scale this carving factor. We still don't have it, so we need to compute that attribute. So we want to drop down a primitive wrangle because we're acting on primitives, but we have all the attribute we are using, like the animation, the distance on the point. So we want to promote the attribute we need after we rotated the spine. So from point to primitive, we want to promote the distance, the anim, and the petal attribute. So we do have those attributes on the primitive level now. So this will be the wrangle for the curve. We will call it curve. And similarly to the rotation, we want to carve according to two ramps, one for the start and one for the end. So we can sort of simulate also a growing effect on the petal. So just like before, create two ramps. The first one will be carve start, ch ramp, carve ramp start. And this will be based on the distance attribute without any remapping this time. So f at dist. And let's copy and paste it so we can have carve end. Same thing for the name, always on the distance. And now we want to bind it to an attribute, so f at carve, and we want to use another lerp. So lerp from the carve start to the carve end using the animation attribute. So now if we go on the carve and use that attribute name, everything disappear because we didn't create this pair parameter for the ramps. But as you can see, we are carving something. If we change just the start, we do have a shortening effect, which is actually opposite to what we want. So let's put the carve end at full value of 1. And for the start, let's see what we want to carve. Let's say something, get rid of the last point, something like this, maybe. Yeah. And also, since KineFX does create a few attributes that we don't need, let's drop down an attribute delete just before the carve operation. And we want to keep the carve, the anim, the distance, and the petal attribute. So delete non-selected. And it should be more clear now. So now let's drop down a resample because at the current state, we don't have a consistent topology. So let's drop down a resample node, not based on the length, but on the segments. So let's resample with 24 segments for each petal. And now we do have a consistent topology. But we might have another problem because right now we lost the U, the correct U for the lines because they are carved. If we recompute it here, and let me just display it very quickly. Since they are carved, this attribute might seem stable, but it's really not. If we change the display type to marker, you will see this number slightly changing over time. And this is not good for what we want. So we want to do a little fix on the U. We don't want to compute it from the resample node. We want to do it with another primitive wrangle. So let's drop down one. After the resample, we will call this correct U. And basically, we want to calculate the U in one of the classic way when you divide the current point number for the total point number, but we need to do it for each primitive. So first off, let's create an integer array for each primitive. We'll call this pt prim and square brackets. And we want to use this prim point function. This will give us an array with all the points contained in a primitive. So geometry 0 on the current primitive, so at prim num. And now for each one of this array, we want to do that operation, the ptnum divided the numpt. So for each int pt inside pt prim, we want to calculate a new u value. So plot new u, and the ptnum is basically the pt variable of the loop, so pt, but we want to first multiply it by 1.0 so we can sort of cast it to float. And since we are not in a for each loop with the nodes, basically when we are iterating on the second primitive, the first point number is not zero, like when you are using a for loop. So basically we need to use the modulus operation. We know that each primitive is 25 points, so this modulus of 25 will ensure that basically when we are done with a primitive, we are resetting the point number. And basically we need to divide all of this for the total number of points, which is simply the length of this array minus 1. So len pt prim minus 1. And now we want to set this point attribute, geometry 0. We want to call this new u. On the current point, the value is the float new u, and the mod is set. So now I'm visualizing this new u I created as marker, and you can see that the numbers are stable because we are basing all this calculation on topology, and we just ensure with the resample on segment that we have a consistent topology. All right, so let's make some order here and get rid of this. Now the next step will be to use these spines to copy other lines that will act as the width of the petal, so we can eventually skin all of this as as an actual mesh, because right now they're only the spine lines. And before doing that, we need to prepare some stuff because we delete some attribute, we did some curve. So basically, all the correct orientation on the curve for the future scatter of the other lines will be messed up. So first, we want to reorient this curve. So take an orientation along curve node, plug it after the correct U, and here we want to set the target up vector as positive y-axis. We don't want to recompute the u, we want to recompute the new normal. And we also want to activate this quaternion. This will output this orient attribute that will handle the correct orientation of the other lines. Now let's take, let's copy this attribute promote we used before and bring it here, because we want this exact attribute, this anim and petal back on points. So this time from primitive to points. And let's check if we do have it back correctly. Yeah. So let's create the line for the width, and we will use two lines. So one will go in the positive y-axis, and the other one will go in the negative. So if we merge these two, having two separate lines, it will allow to bend from the middle this time. And also we want a group on one of the two, so we will be able to identify it, set it as point group, because we sort of need to delete before skin and skin those separately to avoid normal problems. Also, let's drop down a resample so we can decide how many joins, and let's set it to 4. Let's take a copy to points and copy this line on the spine. And it seems correct, the orientation, also the animation is working. Of course, we need to take care of the, let's call it p-scale, to decide the width over the length of a single petal. And also on the resample, let's enable the curve view, but don't call it U this time. Let's call it branch U. We need both of the use. This for the single branch and the global that we're still using for controlling the animation. So in this way, we will keep both of those. We have branch U and the new U after the fix. Also, here we want to transfer the normal. So on the copy to points, just delete this normal exception and also get rid of this. So now we also transferring the normal from the full flower. Let's hide the normal. And before working on the rotation of the petal, meaning the side curl, let's handle the p-scale. So let's take a point angle. Before the copy, of course, this will be called calc p-scale. And inside here, let's just start by creating the attribute. So f at p-scale is equal to, for now, let's just create a global controller just to ensure that it's working, and it is. Now we want to base the p-scale based on this, let me visualize it, this new u attribute. Let's set it as color, ramped. Basically, we want to base it on this. So let's create a float variable, p-scale. We will use a ramp, so ch ramp. Let's call it p-scale ramp, and it will be driven by the new u. Let's create this per parameter, and of course we need to multiply it here. So p-scale by this global amplitude. And as you can see, it's flipped because we want more something like this, but it is working. And we want to set it as B-spline and have something like this. So we have this sort of shape. And also we want another multiplier because we want to use also this attribute. So the outer petal will be bigger than the inside one. So we need another ramp. We call this dist, ch ramp, dist ramp. And this will be driven by the dist attribute we already have. This will go into the multiplication also. And let's create the ramp. And we want the inner to be smaller. So something like this, make it be spline also. And we want something like this. And we can also raise this amplitude and actually add some random factors. So let's create another variable, float rand scale. We will fit 0, 1, a random number over the petal attribute we have. And let's say it will be fit between 0.8 and 1. Goes into the multiplication also. So rand scale by CHF. Now this seems a little too big, so lower entirely the length of the line. Let's make it 0.6. So something like this. Now to make the effect of the petal curling on the sides, we need another rig attribute wrangle. And where we are going to curl the petals on the side, we will use a similar technique we used here, but with less ramp, so less code to write. So let's start with the matrix. So as always, matrix X form, we will use the identity matrix. We want to rotate this matrix for an angle in radians that we still need to create. So let's for now call it angle. And this time the vector for the rotation is not the cross product, but is the normal that we transferred from the main spine. So here we will rotate it by the normal. And of course we get an error for the angle, but it's okay. So plot angle. Similarly to before, we want to lerp between two states. So one will be the start u and the other one will be the end u. Always driven by the animation attribute. It's still there, it's still animated. And for the ramp this time, we still want two angles, a start and an end one. So plot start angle, CHF, start angle, and a ramp. So start u, ch ramp, let's call this start U. And we don't want to use the new U to drive it. We want to use the U coming from the branch itself. So where it was, f at branch U, or it was, yeah, branch U. And like before, minus 0.5, close parenthesis, and close all of this, multiplied by 2, and everything multiplied by the start angle. So I guess we need another parenthesis here to not mess up the operation order. Let's copy and paste it because we need also the end angle. So end angle and U, and change the names, of course. Create this per parameter. Let's hide the normal. And let's see if we have everything we need. Yeah, but of course we still have to apply the rotation. So for at local transform. And this time we don't want to do multiplied or equal. We want to do xform, so the matrix multiplied by the current local transform. And this is on purpose. If we go and look the rotate spine, here we are multiplying by the x form. Basically, here is like this. And this for KineFX is different from this because the order operation when we're dealing with matrix matter. In this case, we need to multiply the X form matrix for the current one before. I'm not sure if it's clear, but this is how it works. So if we start to increase the angle now, let's set it to something like 60. You can see that something is happening. Of course, this ramp works just like the other one. So 0.5 mean no rotation at all. So let's set it like this for now. And if we start to increase it, you can see that they are bending, but one side is bending the correct direction, the other one is not. So let's take a point angle, and this is the reason we made a group here. So on this point angle, let's call it fix. And we want this to act only on the left group, and the current normal will be multiplied or equal -1. So now they are bending in the wrong way, but at least all in the same direction. So let's go back on frame 1, and let's say that here we want a maximum angle of, I don't know, 33 degrees. And let's change it to be spline, so we can set something like this. And right now, this curling effect is acting on the whole petal, the whole hue of the petal. And to fix this, meaning we want the bottom part to be less curved, we just need to add another multiplication here. We have the new hue we calculated here. I'm not sure if we are displaying. Basically, we want to multiply everything for this also. So let's rename this to rotate branches. Here where we're multiplying by the start and the end angle, let's also multiply everything for f at new u, and same for the one below. So now we are also taking into account the length of a single petal. And I believe that's good for the start angle. Let's move at the end and tweak the end one. So let's set it to a lower value, something like 36. And for the ramp, let's do something like this. So we have something like this. I want to add also a little bit of twist to this whole thing, but before doing that, let's skin this flower so we can actually see some sort of 3D mesh. We'll need a split, so we can split the left group And after the split, let's take a skin node going from the left branch. So basically here we are skinning just one side. And you can see that if we leave the skin as it is, we have some weird behavior. Like it doesn't know where to stop. So we want to set the skin as group of n primitive. And we know that we have 25 primitive on each line. So set this to 25 and we have the correct topology. For this side, we want to reverse it and also assign some normal. So we have this and rearrange this, copy on the other side. For this other side, we don't need the reverse one. And these two will be merged back together here. So we do have our 3D flowers. This sim will disappear when we will fuse the point, but we will do it at the very end, even after the UV section. All right, so moving on, or rather going back, because we want to apply the twist, let's make some room. We want to add a twist node after the branch rotation. So let's take a twist node. And in here, let me display it. Let's set the angle to something like 50, and we want to twist on the y-axis, so 0, 1, 0 on the capture direction, and for the length, let's increase it something like 5. So now we should have the twist applied to the mesh. But we want to tie this twist also to the animation attribute because we want the twist to happening at the start, but then go to 0 at the end of the animation. Also because this is really terrible at the moment. So let's scale by attribute. Let's use an attribute called twist that we will compute it right away. So let's take another point angle before the twist. Of course, this will be our calc twist. And in here, we just want to create a twist attribute and use the f at anim we already have, but we need to reverse it. So -1, everything between parentheses, multiplied -1. So hopefully now we should have 0 twist effect at the end and only have it at the start of the animation. As you can see, is untwisting, detwisting while it opens. And that's basically the core of our main flower. All we need to do now is to take care of the UV to do some proper UV mapping for texturing and also add some minor noise on the shape just to have some more variation.